Welcome to the Winedown, an afternoon podcast where two techie blokes sit down over a bowl of wine and chat about what's happening in the world of tech. Enjoy while Scott and Nick open up about their week in technology.
Good afternoon and welcome to the Winedown. My name's Nick Beaujard and with me I've got
Scott.
Hello Scott, how are you?
Hello Nick, long time no see.
Absolutely. Where are we? What alcohol are we talking about today?
Interesting. We are again in the DY Hotel because it's just very easy for us to get here and to set up. But look, alcohol-wise, I wanted to talk about something that isn't today.
Okay, what isn't today?
Clean skins.
Okay, what are clean skins?
Okay, so let's think about you're a wine producer and you're up there, you've got your bottles, you've labelled them, you've filled them up, you've done the whole process, and at the end you've got bits and pieces of, here's half a vat of wine, here's some other stuff, here's some other grapes we've got from over here, and all these leftovers. You'll find that people will just go and grab all that and blend something, put it in a bottle, but because it's not specifically what that brand normally produces, they can actually just go and put it on a bottle and say, look, it's from this area, it's from this year, go for it, it's cheap, just use it. And they actually get a little bit of revenue out of all the leftovers and the other bits and pieces. Mm-hmm. You can also find out that if, for example, you overproduce your wine in a year, and you may want to maintain that, look, it's actually normally in short supply, therefore the price is high. We made like 1.5 times as much this year. If we pump the market with that much, it's actually going to drive the price down, it's not going to be effective. We're just going to take that last little bit and put it into some unmarked bottles and just spit it out there at whatever price.
Calling it clean skins.
Okay,
so non-branded wine that sometimes is as good as really nice wine and sometimes isn't.
In some cases, it actually is really nice wine.
Cool, and you can't tell which is which?
No, you can generally get an idea about the producers have started putting on the boxes like it's from like this area or this state in this year. During the wine glut many years ago, this would have been 2004, 5 or so, we couldn't actually send a lot of wine out of Australia. The commercials just weren't there. There was too much wine globally and our natural international buyers weren't buying it. You go and find all sorts of things down your local bottle shop, and I picked up a case of this clean skin wine, $3 a bottle. It was absolutely beautiful.
Awesome.
Anyway.
Awesome. Very cool.
Some of the best wine I've had.
Cool. There you go. We are going to continue talking about Wi-Fi today.
Oh, Wi-Fi, that's right.
2 of 3.
Podcast 2 of 3.
So last time we were sitting down, we talked about, what is Wi-Fi, what are different speeds, etc., etc., etc. Today we're going to talk about deployment, right?
Deployment, about getting your Wi-Fi to work for you rather than against you.
Okay, so Wi-Fi is pretty ubiquitous, right? It's you need it everywhere. I've got it at home, got it at work, got it in the doctor's surgery. You need Wi-Fi. The supermarket's got it. Everybody's got it. You need good Wi-Fi, right?
You need good Wi-Fi.
What's good Wi-Fi?
In theory, let's just say good Wi-Fi is something that makes you not think about good Wi-Fi.
It just works. It's fast,
it just
quick,
works.
It just works.
It just works. And don't use supermarket Wi-Fi. But we'll come back to that.
Okay, we can talk about security maybe in another podcast episode, Scott.
Yes, there's a good plug.
Look at that, aren't we doing well? All right, so Wi-Fi is really prevalent. We need good Wi-Fi. Good Wi-Fi is Wi-Fi we don't notice.
Yes.
So what affects performance of Wi-Fi? And I'm sure people going out buying decent equipment, because if you don't buy decent equipment, don't expect good Wi-Fi. But what else affects it?
So I'll start by saying it's hard to not buy decent equipment these days.
Yeah.
The access points, they're so far along in the progression.
You've not heard of Wish.com?
Yeah. Okay. Look, if you go and buy a TV today, you don't expect it to last 3 months and fail.
No.
You generally think that thing's going to sit on that wall for 10 years and I'm never going to, like a fridge or whatever. The manufacturing is at that level where these things just work.
So what should someone's thinking, I'm going to roll out Wi-Fi in my building for my staff and my visitors.
Yes.
What do you need to think about? What do you need to look at?
So Wi-Fi is a connection between your device, a phone or a laptop, whatever, and an access point. It's through the air. And if you've got direct line of sight and it's close by, it's going to be really good.
Okay, so we've got to remember, it's not just like TV, where there's one big transmitter that's really looked after and your TV just picks it up. Your device is transmitting and the access point is receiving and the access point's transmitting and your device is receiving. And they're all slightly different electronics, trying to fit a standard, trying to broadcast data across the air. So lots can impact that, right?
It can. And even
amazing it works at all.
Well, think about your TV. Why is there an aerial on the roof?
Oh, so I've got line of sight to the
Or say you've got it's line of sight, or you've got a device, or being like a couple of bits of metal sticking out in the open, picking up a signal that is in the open air, not really affected by other things in the surroundings. And because that's a very low speed signal in that respect, that signal coming in, once it hits walls or glass, it's going to start reflecting.
Yep.
And your TV is stuck on a wall behind 3 bits of concrete and whatever, so...
Yeah, the TV internal antennas don't work. So
that's right.
So things that affect performance. Look out for walls, glass, metal. Yep. Heritage buildings with all sorts of rubbish in them.
Heritage buildings are interesting because they are not just brick; they are big concrete or big stone blocks.
And there's metal
cases.
in them. There's big iron girders
There
and all sorts. Now, I will say that's heritage buildings here in Australia, where we don't have a lot of heritage. Heritage buildings in the UK are very different. But where I grew up, all the buildings were made out of granite, and our walls at home were about 3.5 foot thick. That doesn't let much Wi-Fi through.
No, not very well, at least anyway. Not a good experience.
Yeah.
And this is why when you actually deploy Wi-Fi, you have to think about, where am I actually putting these access points? If you're putting an access point down one end of your house, and then you're actually sitting down the other end through a few walls, a door, some stairs, a bit of concrete levelling and all that, and you're finding, dude, the signal's bad down here. This is a crappy access point. Blah, blah, blah. No, it's a good access point. You haven't installed it correctly.
Okay, so we've talked about walls and installation, but talk to me about signal quality versus signal strength, because they're different things, right? I can have a really strong signal, but if my access point is on top of the microwave, like we mentioned in the last podcast, that's going to affect it, right? So the quality will be rubbish.
And look, this is the same problem with phones as well. You'll find I'm somewhere, I've got 5 bars on my phone, yet I can't get anything done. And this is the thing about the tower could be quite happily transmitting a signal out, or your access point could be transmitting a signal out, but your device can't get a signal back at any respectable level.
Okay, so that's signal strength, how strong the signal is, but then I've got quality. So my understanding is, if there's an error in the data, you'll request for it to be resent. And if you keep retrying all of that, it's going to either really slow things down, or if you're running a protocol that just
Error correction.
Like you're running a game or you're doing a voice call, it's just rubbish.
It is, and you've got to fix these issues, and they're fairly easy to address.
Okay, cool. Distance between you and the access point is obviously one.
There are limitations.
The further away you get from the access point, the signal gets worse exponentially, because it's the inverse square law of electromagnetic radiation. Look at me go.
Alternatively, stay close.
Yes, stay close. So this obviously doesn't happen to mobile phones, 4G and 5G, does it?
This is exactly what happens to mobile phones. There is no difference in concept between a phone with 4G or a 5G signal and an access point and a laptop.
So those antennas we see around are just access points, right, for 4G, 5G? I know there's some difference.
There's some differences, but yes, in fact, this is why 4G works so well.
Yep.
And 5G's got a lot of issues.
Okay.
5G is actually, think about 5G as like 802.11a. It's a faster speed, it's addressed a lot of things, but you've got to be closer, and you've got to have good characteristics going back to the tower, which means all of a sudden 5G is putting little micro towers everywhere.
Yes, and I know
Just
that
for this
because
reason.
I'm sitting in the Dewar Hotel. I have 5G, which is
The one location in Sydney where it
works on Vodafone. Yes, absolutely. So where do I install the access point? Do I put it under my desk? Do I put it under a wall? Do I put it in a metal filing cabinet that I've earthed?
So let me tell you, where I put my access points, I turn them upside down and I put them on the roof as a starting point.
Right.
Now, there's with access points, and this isn't common with the consumer brands, you can actually get documentation on radiation patterns. What this is it says this is the sort of distance and what to expect out of this access point. It means I can go like 10 metres that way and get a good signal. I can go 20 metres that way, but if I go 5 metres that way, I'm out of range.
So it's like this microphone, right? If I talk like this, you can't hear me. But if I talk like this, you can hear
That's
me.
exactly what it is. And most access points, we have a thing called omnidirectional, means they'll cover a general broad, not in a particular point-to-point direction, but they'll go right around in most places in front of the access point.
But it's not a sphere of coverage, right?
It's normally think of it as a sphere, or more of a semicircle.
A semi-sphere?
Semisphere?
Yes.
Yeah, okay. Think of it as a semisphere in front of the access point. Get your access point, the base, which could actually be a metal base plate, put it on the ground, and think about a semi-sphere sitting on top of it. That's your coverage area, but it goes out, for example, 10, 15 metres, whatever it is.
Right. Okay, so
Now,
coverage matters.
however,
Yep.
the backplate of most access points is metal. Don't try to get a good signal when the access point is facing away from you.
Right. That's why it's the semi-sphere.
That's
right?
why, and this is why you put them on the roof facing
down,
such that the signal covers the broad area where people are, and you don't stick them inversed up on the roof, on top of a roof tile, facing
that will
the
just
ceiling.
be good for the birds.
Well, it's good for the people on the above once you actually get the signal through the slab.
Yeah, okay.
So there's lots of things like that. Also, don't stick them in between areas, like don't stick it on a bookshelf and then put metal objects on top of it.
Right.
Don't stick it in a rack and put a router and sit it on top of a switch and then put a router on top of it.
And then have your microwave on top of that. Don't do that.
That's right. I mean, this is why things don't work. There's some really obvious parts to this, and then there's some non-obvious parts.
Sure. So we talked about that. We've talked about there's other types though. You talk about the access point I have with this sphere, but there's things which have they're almost directional. They're almost point to point.
They actually are point to point.
There you go.
So if you think about your average access point, you can pick up for $100 down at the corner electronics store. Yeah, you put it in, you put it on a table, and you can probably pick up a good signal with that. That's omnidirectional. It picks up anybody in the room.
Yep.
Point to point, I can actually get access points, transmitters and receivers, access points, that will go a long way in one particular direction, but they don't go very wide, they don't go very high.
Okay.
Think of it like a laser, but it's not a laser, it's spectrum.
Yep.
But you're literally pointing it off into the distance, and at the other end you've got another one pointing back to you, but you can get like 30 kilometres out of a 2.4 gigahertz
and that's
range.
how some people have created community mesh networks, is by
Yes.
connecting them using
Exactly.
Yagi aerials and stuff.
But if you're 5 metres to the side of it, don't expect to pick up anything.
But also, along that 30 kilometres, you won't be getting coverage, right? If you're down in the ground and it's up there.
That's right. And then you actually start to look at issues around, well, if I'm in that area and someone else goes this way across my signal, what happens?
Yeah, no, good point.
So there's issues, but let's not get into that. But in most people, in a house, if you've got an access point, you can see it, or maybe there's only one wall, or it's not a big thick concrete wall. It could just be a plaster wall with no insulation. You'll probably be okay.
Okay. But in most houses, I'd say, most decently sized houses, you're going to need more than one access point.
You will. And look, I've seen buildings and houses that have actually gone environmentally friendly by putting things like reflective glass in, or glass with the reflective
that's going to
coatings.
break lots of things.
It's great. It reflects the heat. It also reflects the Wi-Fi signal.
Now, building an access point in a room, say
Yes.
in business or at home, is totally different to, and we mentioned this in the last one, a stadium, which is different to a bar or a hospitality venue, right?
Yes.
Talk to me about these a little bit, because I get that the room I might have between 1 and 6 people in my family on one access point. Is what it is.
And that's going to be that. In my case, for example, in my house, I've got 2 access points, one upstairs, one downstairs. And they generally cover the areas pretty well. I know that as soon as I get out to my drive, I start to lose signal.
Yep.
But that's okay. I don't generally spend much time sitting on my drive with my laptop.
Okay, that's good. That's good. It's nice to know. I'm learning stuff about you, Scott. But in a stadium access point, I have nothing most of the time, and then I've got 80,000 people for 2
so
hours.
your stadium access points are not ones that are hitting interference so much. It's not as if there's thick brick walls between people.
Oh, no. That's big and open, yep.
Okay, so they've actually got access points out in the open, but all of a sudden there's all these people. Now, it used to be that, you'd have 80,000 people there, and maybe 1,000 of them have actually got a Wi-Fi device, like a laptop or whatever.
Now, all of them have
now
got one.
Everybody's got a phone. Some people have got 2 phones, and they all want the free Wi-Fi.
So, but not just free Wi-Fi, people also want 4G and 5G to work in that massive concentration.
Ever wondered why your phone calls don't work?
Oh, I know why my phone calls don't work. Too many people. Too many people. Okay.
Actually, very quick segue. Many years ago, we actually got a phone from 3 at the time, when 3 was a network here. They said, hey, video calling. We do video calling. Okay, so I thought, that's pretty cool. Let's try this out. It actually worked. It worked really well. Unfortunately, it was like $7 a minute or something, so it wasn't commercially viable. But 3 at the time were actually going, we will give you up to 14 megabits per second of capacity to your phone. I think 14 meg on a phone. Yeah, previously we were just getting SMSs and
9.6K I got over my Nokia. I remember that.
So the problem was, that you could actually get 14 meg of capacity from your phone to the base station if you were in the right place.
Yes.
What they didn't say, However, a very smart or not marketing person came out and said, this has been so popular, we've had to install a second E1 link into our base stations. Now, for those of you that don't know, an E1 link, which is the backhaul, the connection from the base station back into the network, runs at about 1.5 megabits per second.
Yeah.
So yes, I can get 14 meg to the tower. Unfortunately, the tower's only got 1.5 meg back, which it then shares between everybody.
Everybody who's connected to it.
Which could be
and the other thing
500
you
people.
didn't mention was how woeful batteries were back then. I had one of
yes.
the early 3 phones, and I went, this is brilliant. I watched TV on the train for the 15 minutes before my battery ran out.
I used to carry one of those batteries on a phone. The original phone. Anyway,
Cool. Anyway, we move on.
So,
good Wi-Fi.
good Wi-Fi.
Suits most businesses. It's
Yes.
fairly easy to install.
But first,
Yep.
your standard access points that you get, your room access points, which are, look, you just get a general access point, you put it in the room, it works.
Yep.
Your stadium access points are a very extreme version of that, with multiple antennas able to
Yep.
support multiple connections at the same time, and they could, in theory, support up to 500 users in theory. What's also coming out is, if you think about in hotels, all of a sudden you've got a 1,000 room hotel, and you've got an access point somewhere in the hotel or on each floor, or a couple of ends of each floor, but you've now got in between the hotels all these walls in between each room, and these aren't just like a bit of plaster. These are actually thick plaster with soundproofing and all sorts of other things. And
Yep.
it all affects the signal to the point where you can't really get signals. So you can actually now get small hospitality APs where they actually put one in each room,
Cool.
and they're very low range. Those in, they work really well in the room. The walls tend to filter out most of the signal so they don't go elsewhere, but you still get a really strong signal.
Cool.
So they're really good.
Excellent. Okay, so if you've got a problem, add an access point.
In general, well,
Yeah.
that's the easiest way. Look, the most cost-effective way to get good Wi-Fi is put an access point in wherever you think it's going to cover the most of the house, or the building, or the office, whatever it is. If you've got some weak areas, hey, put a second access point in.
But if you want to plan this properly,
Yes.
do a site survey, right?
Yeah, so there is actually a thing called a site survey where an engineer will go out with a laptop and actually take Wi-Fi measurements at various points on an office floor and produce a heat map. Heat maps is something where it says, if I put my access point here, this is the strength of the signal in all these locations. And you can sort of move that around to the point where you actually get a really strong coverage everywhere.
Okay.
But it costs.
Cool. So I've got these access points. How do I connect them to the network?
So you get a choice here. Clearly you've got to either cable them in, you plug a cable in to connect them, or you can put a bit of fibre into them in some cases to
Yep.
connect them. And you would use fibre if your access point was more than 100 metres away from your switch, because generally Ethernet cables only goes...
127 metres, I think, is the
I thought it was
optimum.
100.
Maybe I'm talking a 10 base 2.
Oh, the coax?
Yes.
Oh, yes. You are, and the punch cards can only be so thick as well. Yeah, that's right. The little monkeys need so many bananas an hour to carry the punch cards back and forth.
Yeah, see how long it is since I did networking.
There
I'll
you go.
leave that up to you now.
Cat 5, Cat 6E cabling, 100 metres. But if you go beyond that, you're going to lose the signal on the copper cable, so you need fibre. The problem is you can actually provide power on your copper cabling to power the access point, whereas you can't provide power on the fibre, so you need a power point.
Cool.
The other option is to look at a mesh, which actually puts your access point connected to a power point somewhere off in the distance with no actual cable coming into it. It's like a power cable. It will actually then relay signals that it collects back to another access point to transmit back into the network.
So that's what I have at home. I have a mesh network at home. So I've got one access point connected by Ethernet cable to my router, and the rest of them are just plugged in and talk to each other.
It works really well, provided you do a little bit of design around it and realise that clearly I'm doubling my use of bandwidth or capacity of spectrum. But you can certainly get good signals in areas where you otherwise would not have anything.
So, but if I'm going to run cables, I should run 2, right?
That's the current way to look at this. Actually, it is and it isn't. The idea behind running 2 cables is that you've got a 1 gig connection into an access point, but because we can get, for example, more than 1 gig of connections coming into an access point, clearly I want to have 2 cables to be able to bond them together and make 2 gigabits per second.
Yep.
But that's actually getting to the point now where we can run 2.5 gigabits per second on one cable. We can run 5 gigabits per second on one cable with the right switch at the other end.
Sure.
Which now gets to the point of where you can get 10 gigabit per second connections going into your access points on the new ones that are coming out.
Okay, cool. So the uplink capacity becomes
Yes.
more and more important now, right? That's
it
where
does.
that bandwidth you're talking about, 5 gigs, the access point, is really critical. And this is the problem with mobile phone towers, right? They've only got so much data coming into them.
This is the problem. And this is the whole thing, like what we mentioned before, where your connection of a single user to the access point is more than what the backhaul capacity to the actual tower is. You've got to make sure your solution is designed end to end.
Okay. So, fundamentally, get access points, orient them correctly, connect them the right way.
Yes.
If it doesn't work, add an access point.
That's the easy way to do it, yeah.
Cool. Absolutely. Mesh networks can work, but remember you're using capacity.
Yes.
That's positioning and placement of
Yeah.
your,
And if-
building your Wi-Fi network.
And your mesh networks, look, if you've got the ability to run an extra Ethernet cable somewhere into the room, like and through the roof of the building, under the house, whatever it is, it's a lot easier to do that for a better result.
Cool. Excellent. Scott, that's been awesome.
Look at that.
We need to talk about security on Wi-Fi, but I think we'll do that in the next podcast, right?
We do. It is a whole
Can of
topic in
worms.
itself. Yes.
Yes, so we should do that. But thank you for being here today, Scott. Really appreciate it.
Thank you, Nick.
Thank you for
everyone.
listening, everyone. If you want to hear about Wi-Fi security, make sure you subscribe down there or on your favorite podcast platform. You can get us on Spotify, iTunes, and almost everywhere else. We're here
Well,
on Facebook, in video recording.
and
this too.
wirelessly.
And wirelessly as well. Yes, absolutely. Scott, thank you so much. Thank you so much for listening and watching. Have a good day.
Thank you, everyone.
Cheers.
Bye.
Bye-bye.